Alright, so I've made a small adjustment to my Lunisolar calendar here. Very, very minor. Um, but I did realize that instead of solar days, using lunar days as the basic unit, um, makes things a lot cleaner. Right? So going from moonset to moonset, you very consistently get 7-day weeks if your day is moonset to moonset instead of, say, midnight to midnight or sunrise to sunrise or sunset to sunset, something like that. It's much more consistently 7-day weeks if your day is a lunar day. This also gives you some extra stuff for free. So I've kept um, 3-month blocks where the central month is the anchor and it includes either an equinox or a solstice. So here uh, we have fall equinox September 23rd, local time, and we have winter solstice December 21st, local time. So those are marked with this little dude. Um, and so I didn't do these 3 weeks. Because we're down in here. It's now Tuesday, so yeah, we're right here. So moonset is around 5:10, just a little bit before the sun. Um, but moonrise is approaching sunrise. So on Saturday, moonrise and sunrise are within just a few minutes of each other because new moon. And at full moon, moonset is at about the same time as sunrise. Really, really close. So yeah, this one right before the full moon. I think the full moon occurs fairly early in this day. I don't remember. I did all of these by hand. Um, yeah, so you notice that 613 is very, very similar to this 607, right? So this moonset is very, very close to sunrise, and this moonrise is very, very close to sunrise, which means this moonset is very, very close to, let's see, this moonrise is close to sunset, and this moonset is close to sunrise. Sunrise or sunset. Sunset should be between 7 and 7:30. Here we've got, at the full moon, we've got 7:12. So from this, you actually get a pretty consistent sense of where the sun is going to be, even though what we're doing is tracking the moon. Which is kind of nice. And as you can see, you very consistently get 7-day weeks. And the number system that I devised works with this pretty nicely because we end up with 7 symbols. Every once in a while you do get an 8-day week, so I did introduce an extra symbol there, lambda. And actually here we get like this block of like 2 8-day weeks sandwiched between 2 6-day weeks. So it can get kind of odd, but if you notice 6 8 8 6, that still averages to 4 sevens. And here we have a 7 6 8 7, so that still averages to 4 sevens. 7 7 8 7. That's kind of as far out as you get. You get like one extra day occasionally, one extra lunar day. But very, very consistently you get 7-day weeks. More consistently than if you're tracking the sun, if you're tracking solar days. And you might notice here, currently it's in the last week of the month, right? So we'll go from this one, this moonrise. So what these two times are a pairing of the moon rise and the moon set, which ends the day. The moon rise will be in the middle of this day, and this this moon set is what ended this day here. So a lot of the time, this time will be from a different day than this time. So yeah, like here, right after this, because this is almost midnight. So we have a moonrise at 1:25 here, but the moon set that started it was at 3:30 in the afternoon the previous day. So the date for this would be the 21st. The date for this is the 22nd, and the date for this is the 22nd. So what this can mean is you can actually end up skipping a day, right? Because here we have a moon set at sunset at midnight, really, really close, just before midnight. And then we have a moon, let's see, there's a moon rise right around midnight. A moon set a little bit past noon, a couple hours, it's like 2:40 the next day on the 20th. But then the next moon, or that's a moon set, the next moon rise is after midnight the following day. So these days that I'm tracking here, because, so this is a full date, right? Sunday, August 21st, 038. That's the only full date that I'm tracking. Because this one you can get from context, because if it's a larger number than this number, then it's the previous day. And this number you can get from context, because if it's a larger number than this number, it's the same day. If it's a smaller number than this number, then it's the next day, right? So 2356 is larger than 1437, so 1437 is the following day, the 20th. But then the 20th gets no direct representation here, so it looks like it skips a day. But it doesn't really. And the table that I got this data from, it was way harder to read these. This format is much, much, much easier. Also, there's redundancy because this set time and this set time are the same, which is why I can just drop in this indicator of that this day is the equinox, because that's where I have a redundancy, and I don't need to add extra space to make it bigger. So that's kind of nice. Let's see. Yeah, so I have on both sides indication of the phase, and then it kind of like becomes less and less like that phase and more like the next phase, less and less like that phase, more and more like the next, right? This I was looking for, kind of just screwing around, just finding a decoration for up here between the footer and the header of subsequent groups, and I came up with that. I was just playing around with stuff, and I was like, hey, that's kind of cool. And then I realized that it fit here really nicely. So it's like, okay, I'm gonna actually use that over here, because there's exactly 7 characters, right? There's the first one, and then two blanks, and then 2 of these guys. So then you just end up with the odd 8th day, which usually doesn't occur. Usually you don't get that day. And then over here, the counts, the day count, but not full. So it kind of gives you a more visual distinction. It's a little easier to see stuff. So we've got planting times, and it tells you which season we're currently in. And they kind of bleed unpredictably through here, just for several reasons. One, it's a lunisolar calendar, so the month wanders a little bit through the year. It will always contain, this central month, this anchor month, will always contain a solstice or an equinox, but it can wander. It can occur at the end, or it can occur like up here at the beginning, so it can jump quite a bit. So the season that we're indicating here will bleed into the anchor month, and this season here will bleed into this anchor month as well. But also, from year to year, the exact time that the seasons start differs naturally anyway. So even if it was a set, um, even if it was a set solar month, like what the Gregorian calendar uses, it would still be the case that these bleed in through that month. So yeah. And then down here, I haven't finished it yet, um, but you can see like that's the basic frame. I just fill that out. And then here, I know there's going to be an intercalary month, and that's going to have a different format because it's not a group of three with an anchor month in the middle. It's a lone wolf sort of thing. So this is the format I came up with. That just a nice clean, just 1 month, basically based on the first month in your 3 month block with this lunar phase indicator on the right hand side. So yeah, I think that's a nicer way to do this. Tracking just the lunar days instead of trying to match up the solar days ends up being nicer. Somewhere in here, I forget where, there was like a 9 day. See, was it 9? See, Saturday. Yeah, the last week of. Oh yeah, that one's interesting. So if you have this month listed as um, solar days, this occurs on Thursday. Because what happens is it's at like 17:30 or something. It's just a little bit after this time. So as a lunar day, it actually occurs on this day. Because it occurs after this moon set. Um, but on solar days, well, on our conventionalized solar days, which are kind of bullshit, um, it would occur on the Thursday. So you do get some things kind of move around a little bit. Um, and because of this, where like a day can sort of get eaten, a solar day can get eaten. So we go from 19th to the 21st, or the 17th to the 19th, 17th to the 19th, or let's see, 15th to the 17th, 14th to the 16th, 13th to the 15th, right? You get that loss of a day. Because of that, it makes the weeks look slightly shorter. And usually those are weeks that would have been long, right? Like 8 or 9 days. It now turns them into 7 or 8 days, respectively. Because it's actually, if we're just tracking the, which makes sense, if we're just tracking the lunar cycles, moonset to moonset, that's a more fundamental component to a lunar month than the solar cycle, the solar day. And I really think that like the layout of Genesis 1, it's actually probably talking about this. It's probably talking about lunar days and not solar days. And historically, a really nice thing that could easily end up getting them confused is if you have your month starting with the new moon, then this day looks virtually identical to a solar day, to the solar cycle. So if you have lay people who don't really understand how the calendar works, but they're like just kind of like following along, and the big important day is this day, they're easily going to, some non-trivial segment of that population is easily going to get confused and think, hey, we're tracking solar days. So I think that's probably what happened historically in the Jewish community, is you went from tracking months like this to tracking months the way that the Hebrew calendar currently does, because the first day of the month, you can't tell the fucking difference. They look pretty much the same. Because moonrise and moonset are gonna be at the same time as sunrise and sunset within just a few minutes. And as far as like an observational uh, way of doing that, it's gonna look fucking identical. Like, yeah, it's gonna be the same shit. It only gets weird once you're like out here somewhere. It only really gets pretty far off out here. Even here, it's not that far off. Um, but I mean, yeah, we're coming off by about an hour each day. So, yeah. Anyway, that's I think that's about everything about that. Uh, yeah, I like this format better personally. It's nicer, I think.